have this in the tutorial session.
So how much time do you have, Ola? I think we're
50,
behind
so,
schedule.
yes.
So,
the schedule says 15 minutes.
okay, so is that what comes?
If you can have it in 14, that would be, of course, be good, but don't sacrifice the talk for that.
Yeah, so as Ola said, Luigi is developed by Spotify, and it's kind of a workflow system. I will go into a little bit. It has some differences to what compared to most other workflow tools, which I will cover a little bit, and how we worked around that to make it work for our purposes anyway. So one of the unique features of Luigi, we go forward here, let's see.
Press down.
Okay, done. Is that it supports both the normal command line operations, but it also integrates with Hadoop. Although that's nothing that we have run used so far, so I will concentrate on the normal kind of command line interface here. But that's a good thing to know. There are not so many tools that can do both of these. Either they are Hadoop workflow tools or command line. So they use it to produce like top lists and music recommendation and so on, running their machine learning jobs and so on. So what should I mention more here? Yeah, most of these I will go into more detail in the coming slides here. So one of the things that it also has that not all of the other workflow tools has is that it can you can start a Luigi daemon on one node, and then you can connect to it from multiple nodes, and then it can kind of do the scheduling in a central way. So you can start workers on multiple compute nodes. So it can kind of help you with distributing computations across nodes in a kind of lightweight fashion. And it's also very easy to install. If you have the pip Python something package manager, you can just install it with the install command. And you might want to install Tornado as well for connecting to a daemon. So it also has a rather nice user interface, not for creating workflows, but for visualizing them when they are running. So they are showing the status of different tasks, like failed, running, pending, done, and so on. And yeah, basically that's it. So Luigi is, I said it's a little bit different than many other tools, and that's how it defines the dependencies. Luigi is more built up around kind of it focuses quite much on the tasks. You define your tasks only, and implicitly thereby you define the workflow or the dependency graph. And that's, if we look at the Luigi task, here I have a pointer. So we have then you have it as a class. It's rather object oriented. And then you implement the requires function, an output function, and the run function. And the requires function, here is where we define what this task depends on. And here we have this task, it's a class, a task, and the requires function will return a previous task. And this is a bit special because now we are kind of hard coding what is our previous task, which in some of the other workflow systems maybe you saw that you kind of define the chain of tasks separately. So that's not the default way in Luigi, but we have. I will show how we have managed to do that anyway. Anyway, and then you define output, and that's basically you define where to store data when you're running. So for example, you can, let's see, we go to the next slide, and here I'm showing some arrows on how we're reusing things that we're defining here in the past. So this requires function. We access it by calling self.input. That will actually, it will take this task and then get the output function of that task. So kind of the output function but of that previous task. Then we get what that output function returns. And that is a type of file object when we're running the command line interface. And then we get the path of that. So here we are also returning a file object. It's called local target in Luigi. And we're creating the file path that it should be stored in. And we have total freedom on how we generate the file paths here. And that's what I mentioned to Maciek, that we can, for example, if we have a parameter on this task, we can include the value of that parameter here in the file name, so to say. So typically we have some kind of tag or something that we change every time we run a new job, and we can have multiple versions of all the output. So that's something that's rather nice. And also we have came to this, we have tended to always use the previous task's file name here and just pad on our any new kind of extension. So then we can kind of track exactly what tasks our data has gone through. So the file names become longer and longer. But yeah, we find it makes it rather clear. And then of course the run method is where you do, you run something. You can either code, of course, some Python scripting or call a command or whatever, but it's all Python. So it's basically a Python library, an object-oriented Python library that you can use as a workflow tool if you want. Anyway, yeah, so when you have defined a task like this, then you can call this task directly. If you have it in a file called mytask.py, you have to tell what schedulers to use. You can use the local scheduler, and here we just say the name of the task. And any parameters, such as this parameter that we set here, with a certain special parameter object, it will automatically create a flag for us with the same name as the parameter. So basically we can have a workflow with just one task like this, and already here it will help us with this automatically created command line interface. So already here it's rather nice. But to define a workflow, basically we just need two tasks, as said. For example, we have this hello world here, and then we have something that will substitute world to your name. And then, as usual in the requires method, here is where we define the dependency, which is the hello world task. So now we can choose to either call the hello world function, then it will run kind of up until this target, or we can call this task on the command line here. So, and it will figure out what it needs to run to get there. So this is the default way on how Luigi is thought to work. And so we have, I tried to visualize here that we have hard-coded our dependencies inside the task. But we have realized some problems with this. Like for example, when you define a parameter here, then you always need to set it to run this task. And if we run, for example, this task, and if we have one new parameter for each task in the chain here, then this, for example, this first parameter, it needs to be passed on through all the downstream tasks. So it needs to be duplicated. And if we get one new parameter per task here, suddenly we will have a kind of a long list of parameters here. And this is just one new parameter per task, but what if you have 5 new? Then you will have like 20 parameters in the bottom. And what if you want to put in another box here in the middle? Then you have to change all downstream tasks and add that task's parameters. I don't know if you see what I mean, but stop me if something is unclear. So, yeah, this is how it starts looking after a time. This is the kind of most upstream task. It's rather short and becomes longer, 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 and longer, and longer, and becomes a bit unmaintainable after a while. So basically, we have figured out a way to work with this in a different way. That we have a Luigi task that defines a whole workflow, and then we create the tasks inside here, and just call each parameter is just input one time. So I will see how much time I have to go into detail on how we do this. I might not have too much time. And yeah, we're because it's an object-oriented language, it's rather easy to create a meta task or meta class that you can subclass from when you do your tasks. That's what we've done, and added some convenience methods. So we have basically we have added some methods that will do some magic for us, so that we can define workflows in a different way. Let's see here. We're using a special method for figuring out our dependency. But okay, no, I don't see too much here. Without having time to go into too much details, you'll see more in the tutorial. We came up with a way to define dependencies that instead of hard coding the dependencies inside the task, here we create this overarching workflow task, and here we dynamically build up the workflow. And we can pass in information to, we send the upstream task information we send in as a parameter to each task, telling what is the upstream task, which is this one, and then it will also tell the name of an output and so on. Anyway, time is too short to go into exact detail on how it works. Anyway, unit testing is also rather easy to do in Luigi. I have recently figured out, and just need to write some test file, fire up your task and run it, and compare it to some example output. And just some quick lessons learned from Luigi. One thing, as I said, to execute the Luigi workflow, you ask for one of the most downstream tasks, and then it will figure out all the upstream tasks. So it's a kind of pull-based triggering. And sometimes that's a problem, because sometimes you have a data set and you just want to run it through the whole workflow. When you have really dynamically generated data sets and so on, it's really hard to make it in a way that you can ask for the right thing. You don't know what the right thing is before you have run the workflow. So sometimes that's a bit limiting. And we had this with workflows were not really separate, actually. They were not really separate from the tasks themselves. These are the lessons learned in April last year. I think that's the most important things. This has been a little bit updated now as we've learned more things. I quickly hinted that we have found a way around this separate workflow definitions. Also, there's another thing about having multiple inputs and outputs, and also name them. And we found out that unit testing is easy, and let's see, okay. Yeah, we basically run everything through Slurm. That's the way we figured that's the most stable way to do distribution of computation in any way. And it seems to work really nice. And that's it.